Okay, so I'm just going to walk through each of the outputs that you get. So when you run a regression, these are the tables you are going to get based on the analysis that we use. So you've first of all get your basic descriptives table, gives you your means for each of the variables, standard deviations, and how many people. Then you get your correlations, all right? And so in this case, we're looking at the correlations of each of the variables with album sales. So we've got album sales, and it's correlated with advertising budget, and that is significant. And we've got number of plays, and it's correlated, and it is a significant correlation. And then the image, which is significantly correlated, all right, which is a good thing because we're going to include all of these in our regression model. All right, then you get this table that just tells you, so we've got two models here. We've got the first model, which just looked at advertising budget, and then we got the second model, which included the other variables. All right, so notice here you've got, again, two models. The first one is just advertising budget, and the second one is advertising budget, band image, and number of plays on the radio. Excuse me. If you had a third model, it would be 3, and it would tell you which variables are included in here. So the things to look for is your R value, which is your correlation coefficient of 0.578. For the first model, only including advertising budget, and then for your second model, you've got a correlation coefficient of 0.815. And then your R squared value, 0.33 and 0.66. So the first model only explains 33% of sales, and the second model explains 66% of the sales. So the second model here is telling us when we put more variables into the model, it explains the amount of sales more accurately than when we only have one variable in the model. Okay, your F statistic, again, this is model 1, only using advertising budget. Model 2 is all of the variables. And this ANOVA table tells you which of the models is significant. So you'll notice that both model 1 and model 2 are significant. So how do you know which one to go with? One of the things you want to look at is your F value. Okay, so the larger this F value, then this is the model we're going to use. Say, for instance, this F value was down to 80, then we would go with the first model. But this is telling us that we have an explanation of sales more so than, with all of the variables, more so than when we just have one variable included. All right, so here's my significance, and this is telling us that this is going to be good. Okay, so your model parameters. So the whole point of regression is to develop a prediction equation. Again, model 1, model 2, all right? And we are pulling our variables out here. So here is our prediction equation, sales. My constant is negative 26.613, 0.85 times adverts, 3.37 times airplay, and 11.09 times image. So if we were going to play this equation out, we would plug in how many adverts. So if there was 10, we would put 10 there. If there was, the songs were played 5 times, we would put 5 here, all right? And image, if we were given a rating of 8, we'd put 8 in here, and we'd calculate this out, and we'd get the number of sales that we get. So this is your regression equation. Where do I get this 47.08? Remember, because it's regression, we've got error in our prediction, and so this 47.08 comes from this table right here, the standard error of the estimate, which comes from the model summary, all right? And so this is the error in model number 2. This is the error in model number 1. So I'm going to go back down here. Okay, so your correlation coefficients, this quantifies the unique relationship each predictor has on the outcome. So notice that the image has the least amount of relationship with sales, and the other two are pretty similar. All right, this over here, your T and your significance tells you that each of these variables significantly contribute to the impact of sales. So if one of these was not significant, we might reconsider looking at the model again. But in this case, all 3 of them are significant. It also tests for multicollinearity. So remember that multicollinearity is if you have variables that are related to each other that you're putting into a prediction equation, you're basically making your prediction equation less powerful. So the collinearity diagnostics tell you that these are contributing differently to album sales. So if we had 0.93 here and 0.92, then we'd say there's multi-collinearity between number of plays and band image. And in this case, we don't, so that's good. All right, another way to check for residual bias. Remember, residual bias is if you have variables that are outliers, and this is what's known as a case-wise diagnostic. So it's pulling the cases. Case number 1, 2, 10, 47, 52 are some of those extreme cases. All right, now what's recommended is you don't want more than 10 cases. In this case, we do have 12, but it doesn't significantly affect our data, so we are still good. In our residual statistics, these are the two you want to look at. You want your Mahalanobis distance to be less than 15. In this case it is, and your Cook's distance to be less than 1. In this case it is. So again, this is telling us that our regression model is decent. Our graphs, you can generate graphs. You want your standardized residuals and predicted values to be equally spread, which it is here. This is a positive relationship between budget and album sales. All right, and so these variables, so you notice there's a few outliers here. Band image didn't contribute as much to the correlation, so that's a good, just a good visual to see what your data are doing. And then lastly, this is you reporting your results. So notice step 1 really is module 1, step 2 is module 2. And this is in APA format, so this is how you would report your data if you were running a regression model with your data. Where do I get all these numbers from? I get them from the coefficients table. So as you look at this, 134.14, 134.14, these numbers in parentheses are my confidence intervals. All right, so you should be able to look through this table and look through your coefficients and generate an APA table. So the whole point of this being that your regression model, you can put as many variables into your model as you want, but you've got to decide which model is going to be the better model to predict whatever it is you are trying to predict.